The purpose of the lab is to prove that the normal force of an object is always equal to its weight if the object is on a level ground. So in this experiment, we are going to weigh a car, like an actual car. To do that, the weight of the car is distributed among the tires. And speaking of tires, pressure is a really important concept. Pressure is the amount of force per unit of area, to be more precise, when the force is perpendicular to the surface area. And as we know, the force in which perpendicular to the surface is also known as the normal force. So we need to find the sum of all tires. Well, we need to find the sum of applied force of all tires of my car to figure out the total, which should be equal to the normal force of the car. By comparing the normal force of the car to its actual weight, which can be obtained by going through the drug scale, we can verify the statement that on a level surface, the weight of an object is always the same as normal weight. I mean the normal force.
We will be checking the pressure. Obviously, this is the front tire. Front right tire. All right.
Dude, you don't want to do that.
What's happening?
Dude, you're telling me you can't check the pressure.
Do I just stick it in there?
Yeah, and then keep it. And they're gonna read it. Read off the thing, the number.
30.5.
Okay. Go, Greg. Just
ready?
Yeah.
Are you recording?
Yes.
All right. Here's the back tire.
Just so you know, so cold, so I'm kind of shaking. And Krek didn't know how to check the tire pressure. So yo.
32.5. Should I just leave it out?
No!
Let's just keep going.
Cap it up!
That's so long. What was it?
32.5.
32.5. Okay.
Dang it, Krek!
Oh. 28.
Are you serious? Okay, my car is really bad. Greg, just keep it like a little bit long so it won't like change the pressure.
What?
They keep it a little bit so you just.
Oh, okay.
Yeah. What is it?
31.5.
Okay, I need to put air pressure. Go.
So we are going to measure the surface area of the tire by using 4 papers around the tire, and we will measure the gap in between them. Alright.
Yeah, that's correct doing it, and later we're gonna use the jack to jack up my car to actually find the area, and I need to figure out how to do it. Apparently I can't, like none of us can jack up a car. And we're gonna do the same step for like the rest of the 3 tires. So I will be only filming this. I don't want to took like 20 minutes of Greg putting stuff in.
Sorry.
Greg, just leave it in. What?
Through the back?
Yeah, like the same thing like for here. Let's look like this. Use the front. It's not dirty. That's what. No. Are you alright? You done?
Yeah.
Alright, now we're gonna jack up the car and like measure like the length and the width of the gap to calculate the surface area. And we do the rest, pretty much the same thing. And I'm pretty that's it for our experiment. I'm gonna say something later. But we gotta learn how to figure out how to jack up the car.
Swag YOLO.
Alright, we just measure the gap by using a ruler, and we want to like measure it in inches because PSI is in
square
yeah.
feet. It's a square feet.
Yeah, square feet. No, PSI.
It's in inches.
Inches. Square inches. Yeah, pound. Yeah, pound for square inches.
Okay.
And we got for the length is like 6 inches, and we're gonna do the same thing for like the thing. Alright, Krek, that's enough. She's not gonna see it. For the calculation part, I figured out the weight supported by each tire. Add them up, and I get my total weight to be 3,005.2 pounds. I took my truck to, I took my car to the truck scale and weighed my car, and the actual weight is about 3,200 pounds. I'm using the old equation from APKM to figure out a percent error by taking the experimental value minus the theoretical value divided by the theoretical value times it by 100 to get the percent error. And it's actually pretty good. The answer is pretty good. The experiment used 6.09% error, which is a really acceptable answer, because normally anything under 5% error is good, but like to do that in experiment like this is like nearly impossible. So I would say anything under 10%, and our groups came up with like a 6.09% error, which is like really confirm my belief. The reason for a percent error is that like the ruler we use might not be accurate because it's a cheap ruler, and the sig fig is limited to 2 digits. Also, I asked D, and he said any pressure guard would satisfy the lab, so I just bought the most expensive one in Walmart, which is still pretty cheap, but it allows me to get 3 sig fig, so it's better than 2, but still it's not accurate because most lab equipment allow me to go beyond 2 or 3 sig figs. Anyway, 6.09% error is pretty good still. And the final reason why we came up with a 6% error is because we did it on Monday, which was a really bad idea because it was freezing outside. The weather was like 8 degrees Fahrenheit, which is way below the freezing point of water. So I don't know, Greg and I might have shaken our hands. Now, going to the conclusion. The applied force, in which is perpendicular to the surface, is also known as the normal force. And by finding a sum of the applied force of all 4 tires, the normal force can be found. And by comparing the experimental normal force to the actual weight, the statement, the normal force of an object is always equal to the weight of itself. If an object is on a level ground, it's verified. We succeeded in doing the experiment. Also, to make sure the lab is right, I did it by myself with another car, and the result came out pretty close. I don't know about doing this, but I'm glad it's over. Have a good break. Oh yeah, and another thing, I would like to, well, my group would like to thank Duy Nguyen for helping our group, despite being forced to help our group, because I was his ride, so he had to Duy had to follow me to Krek Chavez, and we ended up doing the lab together, which is pretty fun.